Welcome back to the deep dive. Today, we are looking at a career trajectory that essentially breaks every rule in the standard playbook for getting a job in tech.
It really does.
It,
Because usually when we profile engineers at major fintech companies, and we're talking about MoniePoint Group today, which is a massive player, we kind of expect a certain path.
right, the conveyor belt approach.
Exactly. A computer science degree, straight A's, an internship at a big firm, junior developer, and then just a steady climb up the ladder.
Yeah, but today we are unpacking the story of Nancy Amandi. And she's currently a data engineer at MoneyPoint, but her entry into the field wasn't calculated at all. It wasn't even intentional. It was, by her own admission, a complete accident.
And not a small accident either. We're talking about stumbling into a hackathon.
Right.
And context is really key here, because hackathons are usually these high-pressure environments where people show off skills they've been honing for years, right? But Nancy joined a team to build an AI product as a product manager. And the punchline here, she didn't actually know what artificial intelligence meant at the time.
I just love that. It's like joining a cooking competition and asking, so what is an oven?
Yeah, pretty much. She's in the room, the clock is ticking, and she realizes she has to manage a product involving technology she literally can't define.
Wow.
Now, most people would just quietly exit the building at that point. But Nancy did something that I think defines her entire career. She didn't fake it, but she didn't quit either. She spent the weekend speed running the definitions. She learned just enough to be dangerous, just enough to be useful.
And that's the hook for our deep dive today. That chaotic weekend woke something up in her.
It sparked the curiosity. She decided, okay, I want to do this for real. But, and this is where we really get into the meat of our discussion, her path from curious to actually hired was full of false starts.
Right. And our mission today is uncovering how that non-technical curiosity evolved into a high-level engineering career. We're going to look at how she navigated the transition from data science to data engineering, which is a distinction a lot of people miss.
Completely miss it.
Mm-hmm.
We're also going to dig into her philosophy on tools versus business, which is honestly just a masterclass in systems thinking.
Plus, we definitely have to touch on the geography of opportunity because she had to make some very hard physical moves to get her career off the ground.
Absolutely. At its core, it's a story about agency.
So let's go back to that post-hackathon moment. Nancy is hyped up. She wants to work in data. Naturally, she does what everyone tells you to do in that situation. She starts learning Python and tries to become a data scientist.
Which is the default setting for the industry. You hear data, you immediately think data science. You think about building predictive models, machine learning, all the sexy stuff.
But she hit a wall.
A very hard wall. She started learning Python, but she found herself really struggling. And I think it's important to explain why this happens, because she is not alone in this.
Not at all.
If you are brand new to tech and you jump straight into data science, you were essentially fighting a war on two fronts. You're trying to learn the syntax of a coding language like Python, and you're trying to learn complex statistical concepts at the exact same time.
Right? It's just too much abstraction all at once.
Exactly. She felt like she was just memorizing code without actually understanding what it was doing. She was stuck. And this is where a piece of specific advice completely changed her trajectory. She saw a tweet from a developer named Gift Ojeabalu.
Shout out to Gift. What did the tweet say?
It was incredibly simple. It said, if you are trying to transition into data and finding it hard, don't start with data science. Start with data analysis.
Okay, let's pause and unpack that for a second. Because to the uninitiated listener, data science and data analysis sound like synonyms. What is the functional difference for a beginner?
That is a great question. Think of it this way. Data science is often predictive. You're trying to build a model to guess what will happen in the future. That requires heavy math and algorithms.
Okay.
But data analysis is descriptive. You are looking at what has already happened.
So looking at sales from last month versus trying to predict sales for next year.
Precisely. Analysis is tangible. You have a spreadsheet or a database, you sort it, you filter it, you visualize it, you can see the results immediately. For Nancy, switching to analysis allowed her to build a mental model of how data works without getting bogged down in the complex math of prediction.
It essentially lowered the barrier to entry.
It did. She picked up SQL and Excel, started actually analyzing data, and suddenly she was making progress. But, and this is the pivot point, as she got good at analysis, she realized something else entirely. She didn't actually enjoy the storytelling part of analysis.
So she didn't want to be the one presenting the charts to the board.
No, not at all. She realized she enjoyed the building part. She liked the technical work of getting the data clean and ready more than she liked analyzing the final results. She wanted to be the mechanic, not the driver.
And this is the bridge to data engineering.
Right. And again, let's clarify the jargon for you. If a data scientist is a chef cooking a meal, the data engineer is the person who designed the kitchen, installed the gas pipes, and ensures the water creates the right pressure.
The infrastructure.
The infrastructure.
Yeah.
Nancy realized she wanted to build the pipes that move data from point A to point B reliably. That is data engineering. And when she locked on to that, everything just clicked.
She found her home in the technical weeds. But what's fascinating is that now that she's a data engineer at MoniePoint, her philosophy isn't tech at all costs. In fact, she seems almost skeptical of technology for technology's sake.
Yes, this is the systems engineering mindset she talks about. And honestly, this is what separates a junior engineer from a senior leader. Nancy believes the biggest mistake engineers make is solution shopping.
Solution shopping. I really like that phrase. Is that when you pick the tool before you actually know the problem?
That is exactly it. A business stakeholder comes to you and says, hey, we have a problem with our customer data. And immediately, the engineer's eyes light up and they say, ooh, let's use Apache Spark. Let's use Kafka.
Because they read about it on a blog and it sounds cool.
Right. They just want to put Kafka on their resume. For our listeners, Kafka and Spark are incredibly powerful tools for handling massive high-velocity data. But they're also complex, they are expensive, and they are hard to maintain. If you use them to solve a small problem, you aren't being smart. You're being wasteful.
You're using a flamethrower to light a candle.
Perfect analogy. Nancy flips the script completely. She says you have to start with a business domain. Before she even touches a keyboard, she asks, what is the budget? What is the volume of data? What is the velocity like? Do we need the answer in 5 milliseconds, or is 5 minutes okay?
And I assume once you ask those practical questions, the answer is rarely the flamethrower?
Exactly. Usually the answer is a simple SQL script or a basic Python job. Nancy's method is to define the constraint, then pick the simplest tool that fits.
And she credits a specific book for this mindset shift, doesn't she?
She does. It was during another hackathon. She really loves hackathons. And she read Effective Data Storytelling by Brent Dykes.
Wait, she read a book during a hackathon? That is intense.
She speed read it. But the core message really stuck with her. Technical brilliance is meaningless without business impact. You can write the most elegant code in the world, but if it doesn't solve the stakeholder's actual problem, you have failed.
That leads right into her strategy for dealing with management. She has a quote that might ruffle some feathers in the tech community. She says, in business, it is not the technical team that drives decisions, it is the business side.
It's a hard pill for engineers to swallow. We like to think we're the captains because we understand the engine room, but Nancy's saying, no, the business sets the destination. The engine room just ensures we get there safely.
So instead of fighting for control, she has a protocol for managing up. How does she get the business to make the right technical decisions?
She calls it making the underlying problem visible. It's a 3-step process designed to build trust. Step 1 is visualize the problem. Don't just tell them the system is slow. Show them a chart of the latency spiking so they can actually feel the pain.
Make it undeniable.
Right. Step 2 is provide options, plural. This is key. Don't just say, we have to do X. Say, we could do option A, which is fast but expensive, or option B, which is cheap but takes 2 weeks.
And step 3.
Recommend the best one. But by giving them the options first, you've given them agency. You aren't blocking them, you're advising them.
It's psychology. You're letting them feel like they made the choice, but you've framed the choice so they naturally pick the right one.
Exactly. She says, this fosters a data-driven culture naturally. You don't force people to listen to data, you show them that listening to data gives them better outcomes.
I want to shift gears here because we've talked a lot about the what and the how, but we haven't talked about the where. And in Nancy's story, the where is a huge obstacle.
The location challenge. This is a real reality check for the industry.
Right. So Nancy was studying in Nasuka in Enugu State, and she's trying to launch this high-tech career. She's applying for jobs. She clearly has the skills, but she keeps getting rejected.
And not because of her code. She would get on calls with recruiters, and they would ask the question, are you in Lagos?
And when she said no,
the conversation just ended. It's frustrating because we talk so much about remote work and the global village, but especially when you are a junior, geography is often destiny. Companies want you in the hub. They want you where the ecosystem is.
So she had a choice. Stay in Nasuka and keep hoping, or do something drastic.
She chose drastic. A few weeks after graduation, with absolutely no job offer in hand, She packed her bags and moved to Lagos.
That is a massive risk, just moving to one of the most expensive cities in the country on a hunch.
It is. But it goes right back to her systems thinking. She identified that location was the bug in her career algorithm. She couldn't patch the recruiter's mindset, so she had to patch her coordinates. She removed the friction.
And obviously it paid off. She's at MoniePoint now. But once she got to Lagos, she didn't just sit in her apartment and wait. She needed to plug into that network. And her approach to mentorship is, well, it's refreshing.
It really is. She effectively banned the phrase, "Will you be my mentor?"
Which is the standard LinkedIn DM everyone sends out.
And everyone ignores. Nancy says curiosity brings you mentors. She believes mentorship isn't something you ask for, it's something you attract.
Can you give us an example of how she actually did that? Because it sounds nice in theory, but how does it work in practice?
Let's take her relationship with Mr. Io Samuel. He was her first real mentor in this space. But she didn't approach him asking for a job or a scheduled weekly call. She just watched his WhatsApp statuses.
His WhatsApp statuses.
It's very specific, right? He would post about AI or data concepts. Nancy would read the status, see a term she didn't know, and go do her own research. She'd read articles, watch videos, and try to grasp the concept. Then she would reply to his status with a specific, intelligent question.
So she wasn't asking him to teach her from scratch. She was showing him, hey, I did the reading. I'm stuck on this one specific nuance.
Exactly. That signals to a potential mentor that you are a high ROI investment. You aren't looking to be carried. You're looking for directions. People naturally love helping those who are already moving.
And that strategy filled up her contact list.
It did. She lists people like Miss Anoma, Mr. Najib Suleiman, Mr. Mayo Akinyel. All of these relationships started because she led with curiosity and did the homework first.
It really seems like agency is the overarching theme of this deep dive. She didn't wait to learn AI, she didn't wait for the location to come to her, and she didn't wait for a mentor to just pick her.
She engineered her own luck.
Let's bring it back to the code for a minute before we wrap up. We talked about systems engineering, but when Nancy is actually staring at a blank script, what is her guiding principle?
Simplicity.
Yeah.
She has a strict rule. Simplicity beats complexity.
Which sounds like a cliche, but any seasoned engineer will tell you it is incredibly hard to do.
It's the hardest thing to do. Writing complex spaghetti code is easy. It's just a stream of consciousness. Writing simple, clean code requires editing. It requires thought. Nancy judges her code by what we call the bus factor.
The bus factor.
It's a slightly morbid engineering term. If you get hit by a bus tomorrow, or more optimistically, if you win the lottery and quit, can the person sitting next to you understand your code?
If the answer is no.
Then you haven't built a system. You've built a trap. You've built job security for yourself, sure, but you've built a liability for the company. Nancy believes great engineering is about maintainability. You are writing for the next human who has to read it, not just for the computer.
That perspective treating code as communication actually perfectly explains her alternative career choice. She mentioned that if she wasn't an engineer, she'd be doing something else.
Technical writing or developer advocacy?
Which makes perfect sense when you look at her journey.
It fits perfectly. A developer advocate is basically a translator between the complex code and the people who need to use it. Nancy has spent her whole career trying to make the black box of data visible and understandable to business people. She loves breaking down complex concepts.
For any listeners who are inspired by this systems first approach, or who maybe want to make that pivot from analysis to engineering, Nancy left us with some homework.
Yes, actual tangible resources.
Yeah.
If you want the basics, she recommends Introduction to Data Engineering by Daniel Beach.
And for the deep dive,
Fundamentals of Data Engineering by Joe Reese. That one is quickly becoming the industry Bible. It covers exactly what we talked about today, not just how to write the code, but how to design the entire system.
And of course, effective data storytelling if you want to understand the business side.
And maybe a sci-fi movie? Nancy is a big fan. She says you need to fuel the imagination too.
Good food and sci-fi, the fuel of champions.
Absolutely.
So as we wrap up this deep dive into Nancy Amandi's journey, what is the big takeaway for you? What's the note you're scribbling in the margin?
For me, it's that technical skills are just the baseline. Nancy didn't succeed because she was the best Python coder in Lagos on day one. She succeeded because she understood the context of her work. She understood that the code serves the business, that location enables opportunity, and that genuine curiosity earns mentorship.
She never lost sight of the why while she was learning the how.
Exactly. She treated her entire career like an engineering problem. She optimized for the outcome, not just the output.
So here is our challenge for you listening today. We want you to look at the last project you finished, whether it was a piece of code, a marketing plan, or a slide deck.
Ask yourself a hard question. Did you build it that way because it was the cool or impressive way to do it? Or did you build the simplest, most effective system that actually solved the problem?
The difference between those two answers might just be the defining factor of your career.
It certainly was for Nancy.
That's it for this deep dive. Explore the sources, check out the books we mention, and think about your own systems. Thanks for joining us.
Keep building.